Okay, example number 5 from the document. My apologies. From the document ztableexamples.pdf. Example number 5. I added a layer of complexity, but it's an important layer of complexity to this one. First, example number 5, generic test scores in the population. I'm asking you to assume a mean of 7 and a standard deviation of 3. That's just given information. A mean of 7 and a standard deviation of 3. That's given. All right? The question that needs to be solved is what raw score falls at the 75th percentile? What raw score falls at the 75th percentile? Now this is a little different because it's asking you to solve not for z, not for area, but for x. You need to solve for x. What raw score? That's what x is. Raw score is data. What raw score falls at the 75th percentile? Well, check this out. I drew the normal probability distribution just like before, and I added 1 line, 2 lines, and a third line. What do you think that third line is going to be for? Well, we'll get to it in a second. I then split the drawing down the middle, indicated a z of 0, a mean of 7, and I added the 50th percentile. 50th percentile. Do you remember what percentiles are? Percentiles indicate the portion of the distribution that falls below, and also indicates the proportion that falls above. So if this point right here represents the 50th percentile, that means 50% of the distribution falls below it, which makes sense because this is the normal probability distribution, and we can cut it in half when we know the whole thing is 100%. The 50th percentile means 50% of the distribution falls below it and 50% of the distribution falls above it. Now we have to approach this one a little bit carefully. Let's go back to the question. But again, before we do that, normal probability distribution, 1 line, 2 lines, 3 lines under the abscissa, z of 0, mean of 7, 50th percentile. Now let's go back to the question. What raw score falls at the 75th percentile? Well, what does the 75th percentile mean? 75th percentile means the point at which 75% of the distribution falls below and 25% of the distribution falls above, right? That's what the 75th percentile means. Well, let's apply that to this drawing. If we know this is the 50th percentile, where would the 75th percentile be? The 75th percentile would have to be here, right? Above 50, 75th percentile. What else do we know about the 75th percentile? Well, if this point here really is the 75th percentile, we know that this portion right here is 0.2500, and this portion right here is 0.2500. If this is the 75th percentile, that means this portion has to be 0.2500, and these two portions together have to be 0.7500. Remember, the 75th percentile, 75% of the distribution falls below it. All right? So now we have area. We know area. So next thing we need to do is find a z-score. So this area right here, we've been referring to this area as the area beyond z, column C in the table. The area beyond z, or column C in the table. This area would be column B, right? The area between mean and z. But we don't, even though it's right there, I know you can see the z-score, at this point in the problem, we don't really know what the z-score is yet, but we need to know the z-score in order to solve the problem. So how can we find the right z-score? How can we find the right z-score? Well, we can do it one of two ways. Either look in the column C for an area. Remember, column C is area, not z. Column C is area beyond z. Column B is area between mean and z. So we can look in column C for a value of 0.2500, or as close as we can get, or we can look in column B for an area of 0.2500, or as close as we can get. And that's exactly what I did. And when I looked at the z table in column C, I found an area Not exactly 0.2500, but pretty close. I looked in column C, and you can do that too. Go ahead and look in column C and find the value that's as close as you can get to 0.2500, and I'm going to guess it's 0.2483. Or conversely, you could look in column B for a value that's as close as you can get to 0.2500, and that value, if you're looking in column B, would be 0.2517. So now that you have the right line in the table, what z-score is associated with those areas? Which z-score is associated with those areas? A z of 0.68. Booyah, now we have a z-score. So you know what we can do now? Go over here to our calculation. Z equals x minus mu over standard deviation. That's been the same all along, right? Z equals x minus mu over standard divided by standard deviation. Except now we're not solving for z, we're solving for x. We know what z is. Z is 0.68. 0.68 equals x, that's what we're solving for, x minus 7 divided by 3. And then I just simply used the algebra that we reviewed, before we got into the semester. I used cross multiplication. I multiplied 0.68 by 3 in order to isolate x minus 7 on one side of the equation. That's what I did here. 9.04. Hold on. Yes, excuse me. I got ahead of myself. 2.04 equals x minus 3, and then I simply added 7 to both sides of the equation in order to isolate x. X equals 9.04, and that is the answer to our question. The question is, what raw score falls excuse me, falls at the 75th percentile? The answer is 9.04, and that's it. Example number 6 is exactly the same thing, except on the other side and using slightly different areas. So please do, and then example 7 and example 8 are pretty elementary by comparison. Depending on how good you are with math, I would recommend watching this YouTube video multiple times, going through those examples multiple times, and testing yourself with your own problems that you make up as well before you attempt the problem set. But hopefully you have the tools, or at least are at the beginning of developing the tools that will help you solve not just these problems about probability, but going forward when we start dealing with other probability distributions.